Before I start to talk about the process of division, I do want to mention once again some terminology with division. You've all seen the type of problem written like this. If you have 12 divided by 3, and it could be written the way that I have just gone through and written it. 12 divided by 3 is equal to 4, and I'm sure that you have seen things written that way. There are names given to each of the parts of this division problem. First of all, the 12. The 12 is known as the dividend. The 3, in this case, is known as the divisor. And the 4, the answer, is known as the quotient. Once again, I'll just be mentioning these words at times, the dividend, the divisor, and the quotient. So it's just good that if I mention those, you know exactly what it is I'm talking about. There are also times that you might have a remainder. For instance, if I had 13 things and I wanted to divide them into 3 equal groups, well, once again, I could put 4 into each one of those groups, but that would mean that I would have a remainder of 1. So sometimes we also have something known as the remainder when we're doing division problems. So what does 12 divided by 3 mean? It really means that you have 12 things and you want to divide them into 3 different groups. So I'm going to make 3 different circles, and if I have 12 things and if I want to divide them equally among 3 different groups, I'm going to start by putting 1 into every group, which is 3 different things. I'm going to put 1 more, 4, 5, 6, another set of 3, 7, 8, 9, and then finally another set of 3, 10, 11, 12. 12 divided by 3 just means, well, how many need to go in each group? And obviously that answer is that I need 4 things in each group. If I had had 13 divided by 3 and I wanted to show that, that would just mean that I had 13 things. I would still have 1 more little line, if you want to call it that, left over. So that would be on the outside. So 13 divided by 3 would mean that I would have 4 in each group, and I would have a remainder of 1. Earlier I had said that one way to write this as a division problem is to have the dividend, the divisor, and the quotient. So if I had this, I could write it that particular way, with the dividend being the 12, the divisor being the 3, and the quotient being 4. But remember, another way that I could write this is I could write this so it kind of looks like a fraction. 12 divided by 3, I could write it that way as well. 12 divided by 3 is equal to 4. This fraction bar also means divide by. So I could write it as a fraction. 12 divided by 3 is equal to 4, and it could be written that way as well. One thing to remember is that all division problems can be rewritten as multiplication problems and vice versa. So if I had the division problem 32 divided by 4, which I'm going to write as a fraction, I know that 32 divided by 4 is equal to 8. If I wanted to, I could rewrite that as a multiplication problem because it's the same family of facts. 32 divided by 4 equals 8 is exactly the same thing as 8 times 4 equals 32. Or if I had something like 7 times 5 is equal to 35, well, if I want to, I could change that to a division problem. It would be 35 divided by 5 is equal to 7. Or I could say 35 divided by 7 is equal to 5. So you can rewrite it. All division problems and multiplication problems can be rewritten using the same numbers. There are 2 special cases to make note of when doing division. What is 0 divided by 5? This means you have 0 things and you want to put those 0 things into 5 different groups. Well, how many things would go into each one of those groups? Well, 0, because you have 0 things. 0 divided by 5 is equal to something. It's going to be equal to 0, and we could show that via multiplication. 0 divided by 5 is equal to, I put a question mark. If I change that to a multiplication problem, that would mean something times 5 would have to equal 0. Well, the only way to get 0 for an answer when multiplying two numbers is that at least one of the numbers has to be 0. So once again, that answer would be 0. 0 times 5 is equal to 0. So 0 divided by 5 is equal to 0. But how about if you have 5 divided by 0? That means you have 5 things and you want to put them into 0 groups. Well, it's not possible to put them into 0 groups. You have to put them into at least one group. So this is something that's not possible. And once again, I could show this by trying to do this as a multiplication problem. If I had 5 divided by 0 is equal to a question mark, if I wanted to change that into a multiplication problem, it would be something times 0 would be equal to 5. Well, what number multiplied by 0 would give you 5? Well, it's not possible because once again, anytime at all that you multiply a number by 0, you will get 0. So this particular answer is not possible. It is not possible to divide by 0. So in math, you could say the answer is not possible. The mathematical term for this is it is undefined. You could say either one. It's either not possible or it's undefined. Just don't say that something like 5 divided by 0 is equal to 0, because it's not. It's not possible to divide by 0. So let's turn our attention to straight division. Let's say we have the problem 162 divided by 3. So I have 162 things and I want to put them into 3 different groups as equally as possible. If I'm going to do that, I could do it the regular algorithm way, and we will certainly talk about that. But I'm going to illustrate this by drawing 3 different circles. And those are the 3 different groups I want to put those 162 things into. Well, how many could go into each one of those groups? Well, I really don't know the answer to that, but I know for sure that I could put 50 into each group, because 50 plus 50 plus 50 gives me 150. So if I put 50 into each one of those groups, 50 times 3 is equal to 150. I could take the 150 things away from the 162 things, and I would be left with 12 things at that particular point left over. So now I have 12 different things. I need to put them into 3 different groups. Well, how many would need to go into each group? Well, I would need 4 into each group. 4 times 3 gives me 12. I would take away those 12 things and I would have 0 for an answer. My final answer to that is 54. So the quotient of 162 divided by 3 gives me an answer of 54, because I would have 54 things into each one of those different groups. This is known as the circle method of doing division, and it certainly is a method that works, but it can get pretty cumbersome depending upon what your divisor is. Think for a moment if this divisor had been something like 15 and you had to draw 15 circles. That would get pretty cumbersome in order to do that. Another way to go through and do this problem is similar to this. I'm going to do the same problem, but I'm going to do it another way. 162 divided by 3. And sometimes people say, well, once again, how many could go into every group? But instead of putting it into circles, they do what's known as the sidebar division. Well, I could put 50 into every group. So I'm going to put 50 over here to the side. And then that 50 times 3 gives me 150, which I'm going to take out again. I'm going to be left with 12. When I have 12 things left over, how many could go into each one of those groups? Well, once again, 4 could go into each one of those groups. 3 times 4 gives me 12 again, which I'm going to take away. which means that I put 54 things into each one of those two different groups. This is known as the sidebar way of doing division. You are probably most familiar, though, with the regular algorithm, 162 divided by 3. And there's not a problem at all with the regular algorithm. It's probably the most efficient method, but sometimes people have trouble understanding exactly why that works. So I have 162 divided by 3. And I'm thinking about this 1 as hundreds place. I'm thinking about the 6 as tens place. I'm thinking about the 2 as ones place. Well, if I do it with the traditional algorithm method, I want to say, and you've probably heard this, how many times does 3 go into 1? Well, it doesn't go into 1. So I'm going to say, how many times does 3 go into 16? Well, 3 goes into 16 5 times. 3 times 5 gives me 15. I'm going to subtract. I'm going to get 1. I'm going to bring down the next number, which is a 2. How many times does 3 go into 12? 3 goes into 12 4 times. 3 times 4 gives me 12. I get a final answer of 54. So, all three of these methods, what I call the circle method, what I call the sidebar method, and what I call the traditional algorithm method, all work. And once again, I don't care what method you choose. It's just important that you get the answers correct. Here's a little bit larger problem, and I'm going to do this the sidebar method and also the traditional algorithm method. So I have 3,527 divided by 9. So I want to put 3,527 things into 9 different groups. If I wanted to do the sidebar method, as I'm going through and doing this, I don't know exactly how many I can put in there, but I know that if I have 9 different groups, and I'm just going to pick a number, I could pick 100. I'm going to pick a round number, a landmark number. If I put 100 things into each one of those 9 groups, well, that's 900 things right there. So I'm going to subtract out my 900. And now when I do that, I have 2,627 things left over. Well, I could put another 100 into each one of those groups and take out another 900. Now, I'm doing this kind of laboriously, but it certainly is something that does work when I go through and do this. If I put another 100 into each group, now I'm left with 1,727 things. Well, I could do another 100 into each one of those groups. 100 times that 9 once again gives me another 900, and I'm going to subtract again, and this time when I subtract, I only have 827 items left. So I can't put 100 items into each one of these 9 groups. So I'm going to try something else. And knowing my math facts, I know that 9 times 90 is equal to 810. So I'm going to put 90 things into each group. 90 times 9, as I said, is 810. So I'm going to take 810 away from that 827, leaving me with 17 items. As I continue to go through this, I have 17 different things I need to put into 9 different groups. So I can only put 1 into each group, which means I'm going to take 9 away, leaving me with 8 items. Well, 8 items means I cannot put any more equally into all those groups. So I'm going to have a remainder of 8 as I go through and do that. Now all I need to do is figure out, well, how many items did I put all together into all those groups? And I'm going to do that by adding up those numbers. 100 plus 100 plus 100 plus 90 plus 1 gives me 391. So my final answer to this is 391 with a remainder of 8. I mentioned I'd also do this just the regular algorithm way. And once again, I don't care which method you choose as you go through and do this. But if I'm going to do it the regular algorithm method, I'm going to say to myself, how many sets of 9 are there in 3? Well, there aren't any, so I'm going to have to say how many sets of 9 are there in 35. Well, 9 times 4 is 36, so that's too many. So 9 times 3 is equal to 27. I'm going to put down the 27, and then I'm going to go through and I'm going to subtract. I have 8 left over, and I'm going to bring down my next number, which is a 2. How many sets of 9 are there in 82? Well, there's 9 sets. 9 times 9 gives me 81. I'm going to subtract. I'm going to get 1. I'm going to bring down my 7. How many sets of 9 are there in 17? Once again, there's just 1. 9 times 1 gives me 9. 17 minus 9 gives me 8, which is my remainder. So I get 391 with a remainder of 8. Once again, I don't care which method you choose. You just need to be able to go through and do the problems and get them correct. Let's do one last problem, but this time make it a 2-digit divisor. So I have 28,732 divided by 26. If I want to do this with the sidebar, first thing I'm going to do is I'm going to say, well, if I have 26 different groups, how many could I put into each one of those groups? Well, 26 times 1,000 is equal to 26,000. So I'm going to put 1,000 things into each one of those groups, and I'm going to take out that 26,000. If I do that and go through and do my subtraction, I get 2,732 items left over. Well, how many can I put into each one of those 26 groups? Well, this would be 100, because 26 times 100 is 2,600. So I'm going to take out that 2,600, and I am going to be left with 132. So I have 132 things that I need to put into 26 different groups. And this is where you might have to do some estimation. If I rounded 26 off to 30, just thinking about that, 30 times 4 would give me 120. So maybe I want to try 4 different groups, but I'm not sure exactly what it is. But 26 times 4, and I might have to do some side math here. 6 times 4 gives me 24. Regroup the 2. 4 times 2 is 8 plus 2 is 10. Well, if I put 4 into every group, that's 104. So I'm going to put 4 into each one of those 26 groups, and I'm going to have 28 left over as I go through and do that. So now I have 28 things into each one of those 26 groups. Well, that means I could put 1 into every group. If I do that, I am going to end up with a remainder of 2, and then I'm just going to go through and add up all the numbers to the side. 1,105 is what I get for my answer, my quotient, 1,105, and I have a remainder of 2. If I wanted to go through and do that the regular algorithm method, I'm going to write it down. I have 28,732 divided by 26, and once again, the very first thing I'm going to do is say to myself, 26 goes into 2 how many times? It doesn't. So I'm going to have to say 26 goes into 28 how many times? Well, it goes in there 1 time. 26 times 1 is 26. Subtract, I get 2. I bring down my next number, which is a 7. How many sets of 26 are there in 27? Well, there's 1. 26 times 1 is 26. I subtract, I get 1. I bring down my next number, which is a 3. Well, how many times does 26 go into 13? It doesn't. So I need to put a 0 in here for a placeholder. 26 times 0 gives me 0. I subtract, I get 13. I'm going to bring down my final number, which is that 132. And then this time when I do this, I can't do the estimation kind of like I did over here, the 4 and the 1. I need to find the exact answer. And I know now that 26 times 5, I can figure that out. 6 times 5 is 30. Put down the 0. Regroup the 3. 2 times 5 is 10 plus 3 is 13. I get 130. So I know 26 times 5 gives me 130. So 26 goes into 132 5 times. I'm going to regroup, and I'm going to put down the 130, and I get a remainder of 2. So I have a final answer of 1,105 with a remainder of 2. And once again, it doesn't matter to me what method you want to use as you go through and do these problems. Just like multiplication, I sometimes find that the biggest difficulty students have with division is having the division facts memorized. But if I can help you with anything in this section, please let me know.